stepping into another time and seeing how life was back then. It's like a journey that I want to be able to re-experience later on. And while I was doing photography there, and actually when I searched online, I saw people writing books about the space as well. It's not enough. It's not the same as with actually going there yourself and exploring it in first person and meeting the people there. And I really wanted to keep this experience. And so I thought, what kind of ways could I really preserve this space? And then I remembered some YouTube video that I saw some time ago about the ability for you to just do 3D capture using regular photographs. So in the video, they kind of scanned a sculpture, took a few pictures of it, and you ended up with a 3D model. And what went in my head was, okay, if you can't do this with a small sculpture, what says you can't really scale this for an entire space, for a building, multiple buildings, or a community? And so, first to understand this technology that we're talking about, it's called photogrammetry. So essentially, you take many photographs and it gets turned into a 3D model. But this process actually has quite a few stages. It's a few academic works combined together to kind of really quickly explain how this process happens. We first start off with a bunch of unordered photos. We don't have any extra information about it. And the first stage we do is we run an algorithm called SIFT, which means Scale Invariant Feature Transform. And it detects interesting points in the image, like corners, like special patches that have interesting textures that the computer can easily recognize. And after this stage, we run point correspondence, calculating point correspondence. So as in, if we have multiple images with features over them, can we actually match up which features are actually shared between photographs? And after this stage, we are ended up with a set of feature points that are shared between images. And another paper called Structure from Motion is able to use this information and run an optimization algorithm called bundle adjustment. And you could actually infer the camera parameters, like how wide its lens is, where the camera is in 3D space, and it could also infer where the feature points are in 3D space. But after this stage, you kind of only have this very sparse model of how an object looks. You only have a few points on it. It's not good enough to be a 3D model. And so the next stage is called multi-view stereo. So once we have information about the cameras themselves, we could kind of really quickly go through the pictures, and we can see, we can have some animation like this where you start seeing something called a parallax effect, where closer objects kind of don't really move that far away, at least in the image space. You don't see it shifting that much. Closer images kind of shift quite a lot, whereas further parts of the image shouldn't shift as much. This isn't a great animation for illustrating that, but generally that's true. And once you have that, you could use this information to calculate the disparity of a photograph, which quantifies for each patch of the image how much shift it has compared to another image. And if you have information regarding the 3D position, you can use this to infer the depth. And once you have the depth, which means you have the distance of each pixel, each pixel's distance from the object itself from the camera, you can then use this depth map to reproject into 3D space, such that each point actually represents a point in 3D, and it turns into a 3D model. So after we learned about this, we actually tried scaling up the process, and these are the actual pictures that we were taking of the space. We were walking through a lot of the interiors. We also took a drone to take a lot of pictures of the exterior, and it took a long time because it was a huge space. And when you're capturing photographs for photogrammetry, there are a few, it's not just taking random photographs. You have some objectives that you want to fulfill. You want to maximize the coverage, so you actually don't miss any part of the space, so you could have a complete model. And you also want to maximize parallax, because if you have a bunch of photographs that are just taken from different angles, but they're still in the same 3D space. You don't get that shift. You can't infer how far they are in the image. So if you want a good 3D reconstruction, your picture should also be diverse in its position. But after we collected all these photographs, it's been actually, I had some friends come in to help in any way. I found I can't really do it myself because it was such a grueling process, and it took 3 months, and we ended up with 76,000 images, and it was like 540 gigs on the hard drive, and it was just JPEG, it wasn't even RAW. So we took a lot of photographs. But after this, we were able to check that we could plug these images into proprietary programs that can implement the algorithms that I was just talking about earlier, and it was able to do these reconstructions. This particular one that you're seeing here right now is just in the sparse stage, so like the points don't really look photorealistic, but the main point is illustrating that it could actually recover the camera positions and the feature points themselves. What's up?
Does this require a lot of computational power?
It does. But the good thing about this is, okay, you'd imagine for like a huge data set like this, one of the biggest bottlenecks would be the memory requirement, because you have tons of images. But like a lot of recent research or like programs like these, what they implement is like called out-of-core algorithms. So they very effectively split this one large problem into smaller problems they can progressively solve. So even if you have like a slow computer, you would be able to reconstruct these. It's just going to be extremely slow.
Right.
But okay, so this is kind of the model we had, and we were quite pleased with it. But after this stage, we just really have a model, and it's not something that's presentable, because our ultimate goal is to use this as a device for storytelling. And having a model like this is not very engaging. And if you just have a model like this, it will kind of feel dead, right? Like compared to actually exploring space, this is just a static model. You don't have the people, you don't have the stories. And so we started also capturing different forms of data, like recording sounds. Oh yeah.
Sorry, in the previous slide, those the black dots and grayness, is that just the lack of data, or is it just that it's not being rendered yet?
So the black spaces here you see are actually the voids of the space under capture. Like these spaces are actually corridors, and these spaces are inside the walls. So like, we're kind of looking at a wall-clipped view here.
Okay.
But so after capturing the model, we tried to capture more diverse data to add into this experience to make it a bit more rich. We captured a lot of environmental audio. We tried very exhaustively to like go to some fans to record audio, or exhaust pipes or dripping pipes. Anything that adds to the atmosphere of the environment was something that we recorded. And we also did a lot of interviews, but not using a regular camera, but instead using Xbox Connect, because turns out the Xbox Connect is really good at capturing 3D volumetric video. So effectively, like what kind of effect you could get from this is, imagine like the hologram of Princess Leia. That's kind of the kind of video you get from this kind of technology. But after having all this raw data, it was still not the end of the story, because we've got the pictures, the sounds, the models, the interviews. But it's not in distributable format, it's just a bunch of loose files. And heck, our point cloud itself was like 20 gigabytes, and so we weren't hoping that people would actually download something like this. We wanted to create an experience that in our Gen Z millennial age, people would actually have the attention span, like something that with a short attention span, you could actually browse. You wouldn't have to wait like 20 minutes for it to load. So we kind of looked into the libraries that were available, and a very interesting library we came towards is called Poetry, which is a web-based point cloud renderer. But the biggest benefit that it brought was the ability for you to load in parts of the model partially, depending on what you're seeing. So like, if you're looking into a room like this, it's not going to load the content that's behind you. Or if you're looking at the wall here, it's going to load the wall at very high resolutions, but it's not going to load something behind you with a lot of detail. So it really effectively used the bandwidth, and it allowed you to instantly see giant models that otherwise, one, couldn't be downloaded, and second, would probably kill your GPU memory. And behind the scenes of Poetry was this acceleration structure called octrees that, if you've been working with 3D data, you might have heard. And it effectively allows us to easily and effectively create spatial queries, given like a huge data set of point clouds, to ask which points are visible given this geometric space. And if you're interested, you can look into that. But after having this whole point cloud being rendered, it's still going to be very boring. It's just going to be like somewhat of a dead model that doesn't have a lot of detail, nothing moves around, and it looks ungraded. Like when you take photos and you don't edit them, it kind of looks boring. So we kind of thought of ways to make it look more interesting, and we did that in the form of shaders. The first thing we did was adding Perlin noise to geometry shaders. In layman terms, essentially, like, we are able to generate this 3D noise, a noise that has a value in any particular 3D space, and this becomes a value that we could apply to the geometry in the scene itself. Like, we could apply this noise as a displacement on the individual points, and we could make the points move around. But I didn't really apply it in this dramatic fashion. Instead, I used the noise and the geometry shaders to kind of really quickly wave around points depending on the confidence during reconstruction. So like what really ended up being was having the points look like they were in a rolling fog, while it would still keep the parts of the model that I was really confident about. So things would still be legible, but it would still have this animation. And we also added bloom shaders, so like bright parts of the model aren't just white, but instead they actually glowed and bleed into other parts of the image, which makes it a lot more photorealistic. And we also added lookup tables, which in layman terms are essentially just Instagram filters. So like you want to make your image look more filmic, you want it to have more interesting colors, that's kind of the way to do it. And in the end, this was the product that we got. And so after doing this first prototype
have you considered changing the hertz range for the audio?
I think the speaker is not doing it a lot of justice. I was kind of mastering this on headphones, so I guess like it wasn't meant to be that sharp, that high. Yeah, it shouldn't be that in a way. But so like after we did this first prototype, we thought, it's actually very promising. And this is something that we could apply to other sites as well. Like, there's nothing that's specific to this one site that we should stand here. And but the issue was that working on a project like this took a lot of labor. So during production, we have to take a lot of photographs. During post-production, we have to do a lot of editing. And the whole prototype took like 4 or 5 months to slowly do. And so what we really need was help. And the first thing that I kind of came to mind was, maybe we could reach out to some relevant organizations. So if they have more resources, it could be technical, or it could be like content-wise, they would know more about the space. It would really alleviate our production process. And so that's what I did. I went online and I found this one organization that did local tours of older buildings, older districts in Hong Kong. And they were covering exactly the building that we were scanning. And I really wanted to know if they had more stories regarding the building that we could really integrate to the experience, or maybe we could provide some sort of a technical solution for them to kind of propagate their content. And I was able to secure a meeting with them. And in the email, it sounded all promising, they're very interested, they wanted the demo. But when we actually went there, things felt like they've turned 180 degrees. Like, they were very cold. And like, when I went there, I kind of explained my project, I did the standard presentation. But when I actually asked if, you were interested, or if you had any resources that we could share, they just straight up said, no, I'm sorry, there's not a lot that we could help you with. But the weirdest thing was that, like, while she was saying this, like, right behind her was this mind map of the people related with this building and all the resources and all the contact information. And she was just looking at me straight up saying, I'm sorry, we don't really have much we can help you with. And so that was really weird. And something fishy was going on, but I didn't really have the capacity to know why. And so I had to move on. I had to find the next best solution. Like, if I can't have people help me with my process, and I still wanted to cover more locations, the next best thing that I could do was start automating the process such that I could work on it with less resources, but a bit more efficiently. And so when we recall the whole production process, one of the things that took the most time actually was the coding part for each experience. Like, you gather all the raw data, all the models, the pictures or whatnot, and you process it, and then you have to compile this into an online experience. You have to care about the UI, you'll have to place the objects in the scene. This took way longer than you'd expect, because we were placing almost 100 objects in 3D space using code. We had to manually enter the coordinates into this space, and there was a lot of fiddling to actually get them right, and it was very inefficient. Like, what if we just had a really nice editor in which we could just put these things into place and make our iteration process a lot quicker? And that's exactly what we did. So over the next few months, I watched a lot of Fireship. I learned my React. I learned Firebase for full stack apps. Apparently it's not great, so don't learn that. I've also learned tailing CSS, which is another kind of CSS library that helps you build UIs faster. And by the end of it, we kind of had a very functional website. So as like a user, you would see this UI, it's nice and all, but this is just one page, it doesn't have much going on. But it allows us to dynamically add content in, and we could just like have something we want to explore, we click into it, and then you instantly have this UI that works on desktop, that works on mobile, that works on WebXR devices like the Oculus Quest. And so it made the production process much faster. Oh, wait, sorry, this is just the viewing part. For editing, you could have a secret sign-in page here, and you could actually click into one of these experiences. You could add multilingual descriptions, and there's a whole interactive 3D editor in which you could just build these scenes with. And right now, this is an empty scene, but you get the point, right? It makes iteration so much faster. But then the post-production wasn't the only thing that took a lot of time. The other thing that took a lot of time was the production process itself, actually going through these spaces and scanning them. These cameras are heavy, and then you go in with full days holding these cameras with the entire team. It actually is very tiring, and so it requires a lot of strength. So we thought, what if we could just put these cameras on wheels and have them drive by themselves in this space? Wouldn't that be perfect? And that's kind of the next thing we moved on to. And so we kind of envisioned up this frame in which it would be very dynamic, it would be configurable. It's almost like a box where you could mount cameras onto it dynamically, and it could just take photographs for you, and it would be on wheels such that it would move into space by itself. And if we look at how the wheels are done, they look like they're configured in a really weird manner. They're kind of configured radially, so if you imagine, you might think it could just rotate in place and not be very useful, but actually the wheels that we use are a special type of wheels called Omni wheels. So instead of being a regular wheel, they could kind of turn, they could move laterally freely, but while being locked in one axis. And as a result of that, what we can do with these wheels is that we could make it move in any arbitrary 2D motion. It could move in straight lines, it could strafe left without turning, it could rotate in place, or it could move in a linear line while rotating in place. And as you can imagine, this would be very useful for the tight spaces that we're traversing. Like, we wouldn't have to make small turns and do parallel parts. We could just directly move our sides. And other than the locomotion itself, we have to deal with the PCB. We initially started with this rat's nest of a configuration. We have an Arduino tied up to a motor driver, tied up to voltage regulators, and it was very unstable, and maybe because things just kept disconnecting. And so we tried to iterate on it, and we had this PCB that kind of encapsulated all the circuitry, and you slap your Arduino on top of it, and it would do all the circuitry for you, replacing all those wires. Except that it was still not good enough. Like, the contacts between the Arduino itself and the board wasn't very stable, and it just kept disconnecting and the bot would go haywire. And so we reiterated that again. We disemboweled the Arduino such that all the Arduino parts kind of now laid directly on our PCB, and that finally fixed our problems. But this was just a part of the PCB that helped drive our motors given like a certain voltage. There's still quite a lot of software that we had to deal with. Actually, first we had to talk about the frame. Initially, we worked with a frame that was made using aluminum extrusions. We had 4 wheels. It was very dynamically configurable because you could move everything around using screws and all. But it wasn't stable because apparently 4 wheels are not a good configuration for robots like ours. Like you can imagine having an IKEA table that has a leg short. It would just kind of wiggle around. And we want to eliminate that problem, and we kind of rebuilt our case from the ground up. We designed a case body in Fusion 360 that had us have 3 wheels instead. And we had it built in some factory in China and manufactured, but it was still kind of shoddy. But I mean, that's what we had to work with. And after the robot body itself, we had to deal with the software, we had to deal with control algorithms, which is essentially, okay, we have this velocity that we want the wheel to reach. How do we actually get the wheel to achieve that velocity, even though it can only control the voltage? And that's a lot that you slowly tune and slowly tap in. We also dealt with the kinematics, the forward kinematics and inverse kinematics of the robot. This problem essentially relates the movement of the entire robot, like having the robot move forward, having the robot rotate, and relating that with the movements of each individual wheel. So, like, how can you actually make the robot rotate? Like, what's the particular speeds of rotation you want each wheel to achieve? That's a lot of linear algebra, but it turned out not to be that difficult. And finally, we had to deal with SLAM. We installed a LiDAR sensor that told us about the environment, and we dealt with navigation, which eventually allowed us to just give it a position in 3D, and then we just drive itself there. And these are some videos of it. This is this robot that was remote controlled. And later, we could just do a position of 3D, which would reach it. But actually, it would avoid obstacles, but it's not very and carry you. Anyway, at this point, it was kind of becoming a problem that I've been spending a lot of money on this project, and it wasn't looking nice. It wasn't sustainable. I couldn't carry on doing a project like this. And so, but I thought I had a lot more done now. I have more sites that I've scanned. I have like a more sustainable way of producing content. Maybe I could start asking for help again. And around the same time, I heard the news that the land development company for the theater that we just talked about earlier was trying to redevelop the building with cultural heritage in mind. So who would be a better candidate than the developers themselves? Maybe they could endorse this project as part of whatever they're going to do there. And so I set up a meeting with them. And you have to understand that I was in my 11th grade. I was struggling with my IB exams. And then I had this meeting set up with this conglomerate with a £2.4 billion market cap. So I don't really know what I was doing, but somehow back then I had the confidence. And it was an interesting experience. Yeah. I eventually got there, I got a reply, and we went to the meeting, and I was faced with a bunch of C-levels, and they were all ready to listen to what I had to talk about. And but apparently, maybe I didn't really get what they want out of a project like this, because when you think about it, they've just invested so much money into like rejuvenating this old building. What they really want from a project like this is good PR. Like, we are a good company, we care about cultural heritage, we do good things, kind of thing. But like, my project kind of stands in the way of that because I'm kind of documenting the stories that became the collateral of the development. And so, as I was slowly sharing about the people I've met, the nice experiences that I've had in this space, I saw the light in their eyes slowly fade. And by the end of it, they were quite polite, they were nice, but like, I was told, yeah, we'll have a think about it, and you'll hear about it from us very soon, and that day never came. And so we were back to square one. We didn't have any resources, but I guess, I kind of wanted to carry on, and we just did more work. We used our old system to see what we could come up with. But as luck would have it, another opportunity came. So there's this restaurant in Hong Kong called the Floating Restaurant, Jumbo Floating Restaurant. It's a giant complex of a boat that hosts a giant restaurant. It's as simple as that. And really, it's been a thing, a landmark within the area for the past 50 years. It's more of a tourist destination than something locals would go to. It has this Chinatown aesthetic that isn't really genuine to Chinese architecture. However, what it has, though, is a lot of value in popular culture. It appeared in a James Bond movie, The Man with the Golden Gun. It appeared in a lot of Jackie Chan movies, and the people have grown to like it as a background element. But also the fact that, within the region itself, it actually used to be a giant fishing harbor, and it kind of coexisted with that. They sold seafood to begin with, but now all the fishing village stuff is gone, and you just have this stuff. So it's a symbol of the past as well. And so you can imagine that people were shocked to hear that the restaurant closed because of COVID, and they didn't have plans to reopen it. And after that, the news that actually got us to care about this building particularly was that one of the parts of the structures of the boat, the kitchen, which was a separate ship, strictly speaking, but it capsized in the middle of the harbor. So it was kind of a sign of no return. Like, there's no going back. This restaurant's kind of abandoned then. And so we started capturing this. After this happened, we can't really get on the boat itself because it's not our property. We did the next best thing. We rented a tank boat to kind of circle around the structure itself. We took a lot of pictures. We had a drone that flew over the structure itself to capture images of it from different levels. And we also had a drone fall into the water, and that was an expensive mistake. But after we captured the data set, news came from the company that, the boat's kind of out of repair. So we're gonna have to repair it. We're gonna take it to Cambodia so we could repair it, and hopefully we'll have better fate there. And the very next day, they towed it out to the sea. And the very next day, it sank in the middle of the Pacific, and that was the end of it. But once news like this got out, I thought, wow, we now have a virtual model of the boat. Maybe this is the perfect time for us to market our project. So I got to work, and I wrote press releases pretending that we were an actual organization. And we have this nice model, so we're not selling nothing, right? It actually looked quite decent. But initially, we didn't really have a lot of responses. I was thinking maybe this no-name project's not going to get us somewhere. But eventually, one night, I got an email back from a correspondent from the South China Morning Post, which is equivalent to being the Guardian, but for Asia. And apparently, they were really interested in the project. And we got an interview, we got an article about the project, and somehow someone even put us on Wikipedia. I swear it wasn't myself adding us to the Wikipedia article, but yeah, that was something. Like, I worked on this project for a good amount of time, finally got some recognition for it, and burned a lot of money for it. Maybe it's kind of time to end and move on to doing something else. It's not really sustainable, it's not going to be sustainable anytime soon. And but before we actually concluded on ending the project, we got another message, a DM. Oh, sorry, I was just saying that I was broken. and said, this time we actually have funding to host a physical exhibition, and we could have physical space for you to materialize your work. And although I come from a computer science background, I've really been interested in doing installations as well. And so we've kind of dreamed up this space that served as like a seance for cultural heritage sites. So like the room was split into two parts. So you first had the first part being the control room. You had a computer that controlled this entire space. And we also showcased a lot of the heaters that we use to create these experiences. And in the second part of the room, that's the actual part of the room that's meant to transport you to different spaces. It was configured as like a meditation area where you could just sit down. It was really cozy. When you first entered there, you would be bathed in this incandescent glow of incandescent lights around you. They were like hung in the ceiling. And they were slowly pulsating. But it was very peaceful. And you had this peaceful Zen music playing in the background. And then in the middle of the meditation room, you had a tingsha. A tingsha being a type of instrument that they use for meditation. So it's kind of like two bells on a string, and you can just knock them together to make a sound, a ding, that is meant to symbolize a moment of awakening. And once you rung the bell, the room kind of lit up, and the lights went from this peaceful to the beat, and the walls kind of opened up to reveal a random space that the users kind of teleported into within the confines of the archive. And further, like right next to them, there's a VR headset that they could don, and you would actually be able to walk into these spaces and see the people there. And you can also ring the bell again, and you'll again be transported to some random destination within the space. And the exhibition was nice, but the making of it was even more fun. Like we wanted this retro aesthetic for the entire space, but we honestly didn't know where to scour for the props for the furniture. And okay, there were prop shops, but they were asking for an arm and a leg. So what we did instead is we just went to these old areas where shops, and we saw an interesting table, and we just told them that we could borrow the table for a month for an exhibition, and we would return it in a fair condition. And that was kind of what happened. And the software development happened all on site after we had this exhibition space. It only gave me around 2 or 3 days to actually create the code that interface with the hardware itself. And it was kind of an actual intensive way where I actually had to see the exhibition venue to develop it, but it turned out to be quite fun. And we got good responses from it as well. I hosted a talk there, and we got another newspaper report on us, and this time I didn't actually write the press release, they just came themselves, and that was an improvement. And you would have thought that would be the end, and at this point, it's already October of 2023, and so it's actually just the first semester of this year, and you would have thought I wouldn't have enough time, and I should probably kind of take a break from the project, but apparently no, I love just fall into the sunk cost fallacy. And I spent more time, and apparently I repurposed my dissertation to work on a related research topic. So one of the overarching responses that I got about the experiences that I have from an older generation is that everything looks pixelated. And this is so low resolution. But they didn't understand the art, it's all art. But we had to cater to this audience eventually, if we wanted a wider audience. And so I kind of investigated into what kind of more realistic reconstructive technologies you could get. And one of them was from a research paper that was just published last year called Gaussian sliding. So to just get the intuition of it across, instead of having a bunch of points for an object, you have like a bunch of 3D Gaussian blobs. They're like 3D balls, 3D fuzzy balls that you could stretch, that you could rotate. And they formed these surfaces, and they had special representations of color such that they could actually model view-dependent effects, like reflections, like refractions. And because of that, and because of the fact that you can model these scenes with tiny fuzzy balls, it could actually model very fine structures that a normal point cloud would fail to. And but it also still has its problems, being that it's still a research technique, and it doesn't scale to large machines. It just runs on memory. And I have product, but it only works behind the scenes, but it looks super realistic. Yeah, I can't kid you. But if you zoom out, it all gets broken. That's kind of the point that we're trying to fix here. But so, up till this point, you know, I've spent 4 or 5 years on this project, and I don't know what the future of this project holds, because it was never sustainable to begin with. I have to burn my own money, and I don't think, like, in its current state, it would be viable as a business out there. And so I really had a deep think of what the project's future should be. And I've made a lot of sacrifices for this project. So, like, I've seen my peers take on these crazy mang internships. Like, you know, I had this one friend that had an internship at Amazon, and then he had an internship at Amazon again the next year, and then at Snapchat. You know, I feel like this is what I'm missing out. There's that FOMO that I do worry about. And so I do often ask myself, have I made the right choice for doing a project like this? But I guess I've kind of came to a realization, because it's not about what the choice is, but it's more of like what the choice represents. The antagonist of the story has never been the land developer that, you know, kind of ignored my project, or the tour company that kind of ignored, oh, I skipped on that part. The reason why the tour company didn't finish from me was because apparently they were working together with the land developer to build the narrative that they were a great company. So that's that. Yeah, but the antagonist of the story is actually the fact that we live in a society that have very capitalist values. And so, like, we really prefer to have projects that have profit over social value. And I guess it's a fact of life that this happens. There's no simple solution to it. But I'm just trying to say, if you have an idea that you're curious about, that no one seems to have done before, maybe it's not because it doesn't have value, but rather just that because it couldn't be easily monetized. And so if you have the passion for it, remember it's all right to, like, take the risk and actually dive into this to see what happens. And maybe you wouldn't get an instant job opportunity, but it's something that you could get a life lesson out of. And also, you might open your doors for some unexpected opportunities, like playing with Linux solution. But that's my talk. Thank you.
Is this working?
Yes. Yeah, there we go. Good. Yeah, thank you very much. Do you have any questions? Yes.
Okay. So I think it's really cool what you're doing, because I actually live near North Point, and I've been to the theater. I bought shoes from the shoe shop that you.
Oh, really?
Yeah.
Okay, that's insane.
But I was wondering why you didn't apply for funding from the cultural department, or just join several competitions with your project. Because I feel like it's really valuable, and the government would probably endorse it.
So I did kind of look into that, but the whole game is, I wouldn't say rigged, but it's not easy to get into. So the biggest organization you can apply to in Hong Kong is called the Hong Kong Arts Development Council, and they kind of have this whole circle of old art people that kind of circle jerk. And you don't really get a lot of chances as a fresh face in the community. You kind of have to build up your profile. You have to have a track record. They wouldn't just randomly grant you $1 million to do whatever you want to. So that was something as a person who didn't even have art education really, other than my high school IB art course. They didn't really have a lot of trust for you to have that much money to work with. So that wasn't really an option for me. But afterwards, having done the exhibitions, maybe that's an option in the future. But I don't know about that. It's kind of a mystery.
Competitions have prize grants or something. I'm not sure, honestly.
But I guess the bigger picture is to run something like this. So the coolest solution is to find a situation where you could make this sustainable. Maybe if you could form this into an actual business model where some organizations that would like to create experiences like this would pay you for it. And currently it's not a thing. 3D scanning for cultural heritage is a thing that's been done for many times before. But the gap in the market for me is that once you scan these things, they just, like these large organizations that do cultural heritage, they kind of keep the models behind closed doors. They use it, maybe they share it to like researchers, but it never gets to the public. But it's actually a very valuable resource. So the contribution that we brought to this field really was publicizing it into a mass consumable format.
Have you thought about making interaction where the user can actually feel the objects?
I think that would be really interesting.
They can like walk in through the room, like they can just walk around the room and they can feel the objects around them. And then like you have the speakers, so it's if you're in the room, you can feel around. So you have the touch, that six sensations.
Yeah, so like I guess what you are getting to is making it an AR experience rather than just an VR experience. And that was kind of what we envisioned from the get-go for the experience. We really wanted to do a thing where we actually had a model within the room that we could map into the VR headset, so we could actually have this interplay between the actual physical space interacting with virtual space instead of just putting you into this virtual space. And when you do that, you could do things like putting an object into where an object should actually be in virtual space. But the thing is, budget and time. We only had a few days.
And another question, did you manage to capture the smells of the room?
I think I'll collect the smells of the spaces in the future. That's an interesting idea.
So I'm interested in the size of these models, just as a technical detail. You said you got like 520 gigabytes of photos of the old theatre, but I think you then said that the model you constructed from that was like 20 gigabytes?
Yes.
So that's like, is that like the final model with all the point clouds and jiggles?
It's actually very variable, and I just gave you a ballpark number. There's many different factors that affect the size of the final model. So first off, like within the original images, how much data do you actually capture? Like, if like the images are clear, you can really interpret as much depth information and would end up with less points. And also, like there's a lot of different storage formats for point clouds. Some of them more efficient, but the others being a lot larger, a lot less efficient space-wise, but allows for easy query, like allows for really faster culling. And
is it more valuable to have lots of low-res images or like a smaller number of very high-res images?
I think a smaller number of high resolution would just give you like a much more detailed model. But I guess you could compensate by using a low resolution image camera, take many close-up photos as well. That's also possible.
Cool.
Okay.
Is there anything you've seen in Edinburgh which you'd be interested in? I mean, obviously Edinburgh's a different environment. It doesn't have any notice group.
I wish I could apply this to a different location, but I think there's a translation that I don't know how it would work out because of like the example I gave of Francis Street. Like nothing ever changed. There isn't the same need of urgency of like scanning these spaces. But I guess like if you look hard enough, that there are opportunities like cathedrals, like it's not cathedrals, but like actual structures that might be degraded by weather, external factors. I don't know, but like I currently don't really see the need for having such a project here. But I'd be interested to see what kind of missed opportunities I didn't do. So I mean, if you have anything you think I should work on, I'm all ears.
Should have the entrepreneurial spirit and create such opportunities. First, find the cathedral and burn it down.
That would be valuable. I should start doing that. I'll also get money to that.
I guess I've got a question. Sort of what Ali mentioned along those lines. There was this company that existed before the COVID lockdowns called, I think it's called Void or Void VR, something like that. It was designed to be a VR experience, kind of like a video game, but you kind of go through hallways in sort of a pre-made sort of layout with physical sensations. So that's kind of linking it to what Ali said. I guess you could sort of take inspiration from that. Obviously, that kind of failed mostly because of financial concerns, which I guess here isn't a problem, and like cleanliness in terms of after COVID and stuff. Because obviously, if you have multiple people wearing the same VR headset, that can be a bit problematic. I don't know if you've got anything to say about that? Or?
Yeah, so like hosting a VR/AR exhibition is definitely a challenge on both the technical, financial, and hygienic parts of the story. And but I think it's improving. So like I did like kind of look into whether I could borrow gear from like those are VR experience companies that they also exist in Hong Kong. Like they have shooter games in which you could just pay to experience. Yeah, cleanliness is definitely a thing that isn't really easy to solve, but we try to address that by having these removable masks that you can put on before you put the headset on. But technology also plays a huge role. Like when those VR shooting companies, VR experience companies first came out, like they were only using stuff like the Oculus Rift, and it required a lot of gear. You had to have all these trackers in this space, and you have to have this backpack that had the computer, or you wirelessly streamed it somewhere else. But if you have 10 people in the room, that would cause a lot of interference. So that was a giant challenge. And when I was thinking about making the exhibition into an AR experience, which never ended up being actually AR, but the hope that I had was I wanted to leverage like the new all-in-one VR headsets for doing this, because like with things like the Meta Quest, you no longer have all the bulk of setting this entire space up just for this one AR experience. It becomes so much lighter and easy to maintain. But the issue was these headsets themselves, they don't have shared tracking. They all track locally within its own space. So that would have been my other dissertation project, to sync these headsets together. It was like, but yeah. So I do think the landscape is really changing really quickly, and I don't really know. Maybe it would be a lot more feasible just in a few years' time with Apple Vision.
Okay, thank you. Anyone else have a question?
What's your dissertation project?
So it's about scaling Gaussian sliding. So currently, Gaussian sliding is trained as like a reverse inverse memory model. Think of the Gaussian plots themselves as a machine learning model. So you have the task of recreating the images with known poses. Like let's say we took 100 photos of this space. We know where they are in 3D because of photogrammetry. We reconstructed the location using photogrammetry. We know where the cameras are. And now we also know what the camera should see. And so the problem of Gaussian sliding is, given a bunch of Gaussians to start with, how can we change and morph the Gaussians such that we eventually morph these Gaussians in a way that make them appear the way they do in the images themselves. The loss function is the difference between the rendered photo and the actual photo that was taken. And this whole process, this whole optimization process happens in PyTorch. And currently what happens is if you optimize the scene, everything gets loaded, all the points get loaded, all the parameters get loaded. And so if you have a scene that's rather large, you eventually get to a point where you simply cannot optimize the scene. So the problem that I'm dealing with is how do you split this optimization problem into smaller problems such that it can be done sequentially and it will be feasible to do larger scenes. And a very straightforward way of doing it is cutting into a grid and then doing them separately, but that has its own problems because apparently one model, one part of the grid actually appears in another part of the grid and they interfere with each other. And so my whole paper is about exploring how do we mitigate this problem.
Okay, cool.
Alright, anyone else?
When's the TED Talk?
Yeah.
Eventually.
Alright, well, in that case, thank you so much.
Thank you.
Well, that's the end. If you want to have anything else you want to say?
Nope, that's it.
Okay, one thing I want to say is that for everyone going to HTV, good luck, that'll be on the weekend. On Sunday evening at 8 o'clock, we're going to be at Potter Row Bar.